Hi guys, and welcome back to Specimens. I hope you've all had a restorative break. If you celebrated Christmas or any other religious festival, then I hope you had a wonderful time and you're able to cherish special times with your family, whether that was over Zoom or perhaps in person if you were lucky enough to not be in lockdown. Here in the UK, we're still in lockdown, and as I record this, it doesn't look like we're going to be out anytime soon. So I hope this podcast is bringing all my fellow United Kingdom residents a little bit of escapism. Today, I'm bringing you a podcast with somebody who is a fascinating museum conservator. He's got lots of experience, he speaks so eloquently and for a really long time about all the things that interest him and started to interest me, much to my surprise. I found him absolutely fascinating and absolutely charming. I really hope you enjoy this episode. Simon Moore is a natural history conservator and curator specialising in fluid-preserved specimen, taxidermy, entomology, botany, the use of microscope slides, and freeze-dried specimens. He also delivers training courses in the conservation of these materials, has contributed to a near endless list of journals and publications, and has been a continued ambassador for the education of natural history and the conservation of species. Before we deep dive in what has been an incredible professional experience, I would love if you could take us right back to the start, to a young Simon Moore. Were you always fascinated with the natural world?
Oh, definitely. Ever since I was young, really young, I was sort of articulating speech and so forth, and at the same time I was watching flies on the window, bees buzzing past in the garden, spiders on webs, all that sort of thing. And when autumn came along, because we lived in Tunbridge Wells at the time, and we'd go out for walks on the common, and I'd start finding all these pretty fungi, which are in fact fly agarics and so forth. I was absolutely fascinated by them, and I thought, wow, where do these come from? And my mother certainly put up with a lot, because my early attempts at natural history, of course, meant sort of picking up dead mice as well as fungi, which eventually rotted, even though I put them in a nice little moss garden on our back doorstep. So it was really quite sort of colourful and sometimes somewhat odoriferous, and I soon learnt about decay and so forth.
That's very sweet. And what about during your education?
When I was at school, it was during an era where natural history wasn't quite so much appreciated. The school's attitude was more towards sports, games, fitness, and all that sort of thing. So when I was out playing cricket on the cricket field, which bored me intensely, then I would sort of squat down and watch the ants greeting each other in the grass and so forth. Then suddenly the ball would go screaming past me, and everyone would yell my name and say, "Wake up, you Daisy, whatever." And I would sort of come out of my little, not quite reverie, but my nature study, if you like, and go herring after the ball. Fortunately, I was quite a fast runner anyway. When I went to a more senior school, I particularly wanted to do biology, and for quite some time, because again, it was in the countryside, in the Berkshire countryside at Bradfield. It was absolutely ideal for what I wanted to do, so I was really, really happy with that. My mother was probably quite relieved to see me out of the house for quite a while. So when she went to open a matchbox, say, and didn't find a huge great bumblebee inside it instead, and she could light her cigarette. Unfortunately, she smoked quite a bit. Then at least I wasn't there to be somewhat annoying in that respect, because I did not approve of smoking at all. So I was always trying to sabotage my mother's attempts at smoking. But certainly when I was at Bradfield, it was absolutely ideal. There were biology labs there, there were specimens in jars, and I thought, wow, fantastic. We had to do a lot of dissections, some of which would be rather frowned upon today, but this was back in the 60s. But it certainly taught me a huge amount about animal anatomy. We were studying all the anatomical names, the names of nerves in fish, amphibians, reptiles, mammals, and so forth, and you had to learn the whole damn lot, including all the vascular system too, all the blood vessels and the names, and then there was a lymphatic system, etc., and it just went on and on and on. Also, at that time, we were encouraged to do natural history projects. There still is ongoing, the Hollowell project, as it's called, which was to encourage boys, particularly. It was just boys back then, but now, of course, it's co-ed boys and girls, which is much better. I did my first one on ants, and I was really encouraged, and I was taken to places where there were wood ants, and I was able to collect part of a nest and see their hierarchy in their ant colony, and then the next year I was onto snakes as well. Not everyone's cup of tea, so it all rolled on very, very happily, and I was obviously looking for a career in natural history. So when I finally left, I was encouraged that perhaps the Natural History Museum in London might be a good place to go. So I duly turned up, and they seemed to be very pleased with me. Because I didn't have a degree or anything at that stage, I was still much too young. I joined the Natural History Museum in their scientific staff and their scientific departments, basically as a junior tick, what we used to call a scientific assistant in the arachnid section. So although I only spent a very short time in the arachnid section, I was there for 9 months, because my heart lay in the preparatory side and the conservation side. And conservation, I mean specimen conservation. But during that time in the arachnid section, I found spiders particularly absolutely fascinating. And I've managed to augment that knowledge considerably since I left that section. In the end, very late that year, I was seconded to what was called the histology and preservation section. So I was doing largely human work from the local hospitals, and learning all sorts of things about histochemistry and so forth, which was extremely interesting to me because I'd studied A-level chemistry, and I managed to get myself qualified, which was very useful. And I stayed in that area for another about 12 years. Then, due to the inevitable reshuffles and so forth, which are always going on in large institutions like that, I was moved into the Cnidarian or Coelenterate section, which is basically the study of lower animals like jellyfish, hydroids, corals, sea anemones, all those sorts of rather strange organisms that are usually associated with the sea. I now became a fluid preservation expert, which was really, really good. So by the time I moved into the Cnidaria section, with all these various strange organisms, some of them extremely fragile, some of them having been fished from great depths of the ocean and so forth, once I'd been introduced to taxonomy of hydroids, jellyfish, and also to an extent sea anemones and corals as well, I then started working on the collection. And it was absolutely fascinating. There were all sorts of extremely important specimens hidden in there, of course. Quite a lot of type material, which is the original material that was used to describe / designate a species. And during my time there, I worked on particularly Cubomedusae, or box jellyfish, which I'm sure many people are very familiar with, and particularly those who visited Australia and those sort of parts of the world where these organisms exist, and often threaten people's lives because they have particularly vicious stings. And they are a group of jellyfish on their own, quite different. And I was able to write a rather crude identification key to them, so I could identify a lot of the unknown specimens in the collection. And some Australians got to hear of this and very generously allowed me to help them, if you like. And in return, they allowed me to designate a new species of Cubomedusan, which was very good. So that sort of helped my career a little bit more. And at the same time I was doing this, I was looking at studying all the various fluid preservatives that these specimens were kept in, and trying to improve their condition all the time. So gradually, over quite a few years, the collection improved, and other people who have worked in the collection since have said that I did a pretty good job. So I thought, hooray, 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 hooray. Because working there at that time could be quite difficult, and I did have one or two slight job mishaps on the way, as one does, unfortunately, every now and again. So it wasn't always plain sailing, but one just took the rough with the smooth, as one has to, and just get on with the work and try to look as happy as you can. Then there was yet another reshuffle. Oh, God, it was so depressing. And a lot of people left the museum, and they pruned the scientific staff. And I was by then getting a little bit fed up myself anyway, and so I was hoping I was going to be on the pruning list because I was still young enough to go off and find myself another career somewhere else. But no, because I've been working so hard, oh dear, I was not on that list. So eventually I was moved into free-living nematodes and basically just became a glorified nematode identifier. And then they wanted me to start doing statistics and mathematics, which I'm not very good at. The sort of basic arithmetic is fine for me, but otherwise, no thanks. I started looking around for another job and found myself working eventually in the Hampshire County Council Museum Service in Winchester as a conservator of natural sciences. And while I was at Winchester, they weren't breathing down my neck every 5 minutes and asking me to fill in reports or attend meetings every 2 moments. So I was much happier there. That was a really good move, as it turned out. And at the time, we were looking to try and start a group for natural history conservation. And by that, I don't mean nature conservation, I mean natural history specimen conservation. And rather luckily, there was a conference in Madrid in 1990, and I went there to give a little poster on some of the work I was doing and basically introduce myself to the conservation world, i.e. worldwide, at large. And it was so useful. I met so many contacts there from them, from the Americas and so forth, Canada as well. And it was all a little embryonic in those days. But as a result of that, we eventually founded the Natural Sciences Conservation Group. Very small, very underfunded, but enthusiastic, and managed to get ourselves sort of heard and so forth, and really get things moving. So that was fascinating. And at the same time, I met other taxidermists as well, because I joined the Guild of Taxidermists. That seemed to be very useful because I was maintaining and looking after taxidermy all the time. And I needed to try and find ways and means of improving taxidermy, either so that it wouldn't deteriorate, such as preventive conservation, or I was actually trying to look at techniques which other people used, so basically to try and improve the basic technology of conservation of taxidermy specimens. Now, a lot of them are very reticent about this because basically it was trade secrets and all that sort of stuff, and I thought, oh dear, that's not very encouraging, because after all, we're trying to sort of spread information around rather than try and rival each other. So I was a bit disappointed by that, but never mind. So I started sort of getting my head together with one or two of the other conservators who were not taxidermists, and I went to train with a taxidermist briefly, just for a few days, to learn basic taxidermy, so I could understand all the mechanics, biomechanics of it as well. Very useful. But I decided that there were plenty of taxidermists who were a lot more expert than I, so I just stayed in conserving instead. But now at least I knew all about armatures and the fillings and mannequins and so forth, and how to prepare skins properly. And I was extremely grateful to other people who were so generous with information. And I started writing many more sort of short articles, nothing sort of in depth, to try and help people on. And it just basically went on from there. Eventually, the Natural Sciences Conservation Group joined up with the Biology Curators Group, and that was basically the starting of NATSCA, the Natural History Sciences Association. And I sat on the committee for a few years. Anyone who found some sort of new technique, some sort of new science or technology like that was always welcome, always encouraged to tell us about what they discovered, and then it was discussed a little bit further, and there were ways of extrapolating from this and taking the techniques even further. And an example of this was some years ago, back in the early 2000s, when I attended a lecture on Japanese tissues from an art conservator, and they basically told me all about the various types of papers that are made in Japan, the characteristics of them, and a lot of Japanese names, of which I remembered a few. And that really opened my eyes. And I thought, well, I'm sure I can use a lot of these for natural history conservation because they're very discreet, they're very strong. You could give them so many applications. in repairing particularly taxidermy, and they made very nice, discreet, as I said, repairs. And then I took it a step further and started to look at repairing broken insects. These are pinned insects, particularly butterflies, and butterflies had been damaged by pests, so sometimes the wings had been shredded. And this was really sort of eye-watering work, I must admit. And it took me a little while to develop a technique that would work, but eventually it came with a lot of persistence. Then I started to experiment a little bit more on actual collections and started to repair them, get them back into shipshape condition. And one of the titles I also hold is advisor on natural sciences to the National Trust. And that was very useful too, because at some point they acquired a cabinet of natural history specimens, about half of which were butterflies and moths, which Beatrix Potter had used in her illustrations, so extremely important, some of which had obviously suffered the ravages of time. So I started putting these together, slightly heart in mouth, as you can imagine. So I was working on this Beatrix Potter material, and then it started to go together pretty well, which was good. And they asked me to come up to Ray Castle, the Lake District, and demonstrate to the general public at large how I was doing this. And so I did that, and I kept some of the easier stuff to do up there, so they wouldn't see me muttering away in the background and uttering the odd expletive when something didn't glue quite as I wanted it to, but might need reversing. It all went pretty well, and all the specimens went back together again without any casualties. I heaved a sigh of relief that it had gone well, and the trust seemed pretty impressed. So that sort of work has always been to the fore with me. I'm always trying to advance the technology of natural sciences conservation. And certainly when I started off back in the 90s, it was, as I said, pretty embryonic.
My goodness, Simon, that was the most wonderful summary. And there are really so many things that I would love to pick you up on there. I think I'll start with asking about your role as a conservator. So you talked about it being embryonic when you first started. And I'm just wondering how many of you there were when you first started out. Because as I understand it, conservators are very far and few between. I imagine nowadays it's a reflection of funding and museums not having the grants or the allocation of funds to employ a conservator. But your skill set is so varied, but yet it feels so niche. So am I right in thinking that there were few of you, but yet there must have been enough for you to have these wonderful societies and organisations that you so eloquently spoke about?
Well, to an extent, yes, that is true. There aren't that many of us. It is rather a specialised area, as some people seem. But particularly when you consider how many conservators there are for fine art, works on paper, textiles, and so on and so on. There are a lot more conservators in there, and a lot more of the colleges that train conservators, give them degrees, tend to do these sorts of subjects, which are quite safe. They've been studied for a long time. The techniques that they use have been tried and tested over many years. Whereas natural sciences, as I said, back in the 90s, was pretty embryonic. It was a little bit sort of, well, let's try this and see if it works, and if it doesn't, never mind, we'll keep trying. But with some sort of scientific background, training, and so forth, for which I'm eternally grateful, I managed to develop quite a few, in their own way, embryonic techniques too, and left those. I just sort of published articles on them, as I said, rather short, rather shallow articles in their way, but at least it sort of got the ball rolling. And then I started training people, doing actual proper formal courses, and the first fluid preservation course took place in 2006. And there I was training an assortment of people, basically, those with natural history backgrounds, those with no natural history backgrounds, but who were multidisciplinary conservators themselves. And ever since that, I have been training people exactly in the same way, from all sorts of walks of life. Some have very little knowledge of natural history, as I said, at all, because they've worked on fine art or something like that. But every now and again, a piece of taxidermy or something might come their way. So I thought, well, in that case, I'll develop a taxidermy conservation course as well. So after so many years of doing the fluid preservation course, then the taxidermy conservation course came along as well. Once I'd sort of found out a little bit more what people really wanted, we started working on museum collections, which weren't very important. So if they went slightly wrong, well, not to worry too much. But they never did, thank goodness. And then sometimes there were a few questions about the technique and perhaps this might be better and so forth. So all the time it was developing, improving, which is just what I wanted. And now there are more trained natural history conservators out there. I always like to think that I had a hand in training a great many of these, but I'm sure that's not strictly speaking true, particularly these days. But always so important to keep passing the technology, the knowledge on, and always encouraging people, because people say, oh, I have no knowledge of chemistry at all. No, that's no problem at all. Don't worry about it. If there's anything you don't understand, or I start sort of babbling on about organic molecules and so forth, just say, can you please give me a little bit more explanation? Don't be ashamed or anything like that, which is exactly what I want, because I want to make absolutely sure that all the gaps in their knowledge are filled. And if they want me to start burbling on about aldehydes or something, then fine, I will. Because they are, after all, rather important, particularly when you start to look at the reaction of formaldehyde with proteins and so forth. Anyway.
Well, that's very interesting, because you bring me on to a question that I did want to ask you, which was sort of centered around the extrapolation of data. So you're keeping these specimens, whether they're in the form of taxidermy, they're wet preserved, there are a whole host of different techniques that you've mentioned. But as I understand it, some specimens will lose the DNA due to the way that they are submerged in formaldehyde. I imagine that denatures them. So what is the benefit? It's something I was quite interested in learning from you. Why would you use one over another? And when would it call for, let's say, having a fluid preserved specimen over a taxidermy specimen, which you could read the data from? Am I making sense on that question?
Oh, yes, absolutely. And basically, fresh material, if you're going to fluid preserve it, does need what we call fixation, which is the basic first step of preservation, whereby vulnerable tissues like proteins and connective tissues and things like that, which would otherwise rot, decay, are stabilized, is a vital first step. And people often tend to forget that formaldehyde, although yes, it does have all sorts of nasty user problems, it's toxic, it does nasty things to your mucous membranes if you start breathing it in, so you obviously have to protect yourself, gives you dermatitis, it's carcinogenic, etc., but providing you're acting like a proper professional and you know exactly what the risks are and you take all the precautions, there's absolutely no problem at all. And it takes me back to the time when we were doing A-level dissections and breathing in masses of formalin fumes. Sorry, formalin is the diluted form of formaldehyde, which is a gas which dissolves in water at 36.75 or something percent. And we were breathing in these fumes, and sometimes we'd end up with slight headaches and so forth, but nothing too sinister, thank goodness. And back then in the 60s, it was rather sort of, oh well, just get on with it, don't worry about the risks too much. So formaldehyde, very important to stabilize all those tissues. Now, if you keep a specimen in formaldehyde for too long, yes, it will affect the DNA. So you have to be very careful not to leave it on, say, I think the limit is about a week before it starts to make any sort of serious alterations to DNA. And DNA preservatives, there are quite a few of them. You can take samples, you can fix them in something slightly different, like dimethyl sulfoxide and so forth. There are all sorts of various other things. And everyone has their own little pet way of doing it. And sorry about that. Every now and again, I'm afraid you'll get a little warm sound like that, which is me just sort of trying to stop the computer from going to sleep. So the formalin stage, the fixation stage, is very important. And as our sort of NATSCA group, Spinach group, various other people who have worked in anatomy museums particularly, and who themselves are also very distinguished chemists, more so than me, have been trying to find a better sort of panacea for fixation, and various techniques have come out, various other reagents have come out and so forth. At the moment, there are various things being considered, but of course, always it's the test of time. How will these specimens be in, say, 30 years, when myself will probably be in the ground, and some of my older colleagues too. The rest, the younger ones, will probably have retired or moved on maybe to something else. So it's always ongoing, and to try and transfer that problem onto something else, and hopefully they'll see it as a challenge and can take it on. So if you're looking at something like dimethyl hydantoin, or hydantoin, as some people like to call it, or what's the other word for it? Defacal, I can never remember which way around it is, which is another fixative, totally different to formalin in its chemical formula, but otherwise it does the little ionic transfer that you get with fixation. Sorry, I'm getting a bit sciencey again here. Right.
I'm glad you clarified what those words were, because for a moment I thought you were talking a different language.
Sorry. So basically it does that. So in other words, it stabilizes the proteins and tissues in just the same way. And we'll see how it works. At the moment, it's looking promising. Anyway, so having started off with your fixation, you then go into the preservative, which can be all sorts of things. You can go into a glycolic preservative if you like, which can soften some tissues, but most people prefer to use ethanol, as they call it, ethyl alcohol, and because of the customs regulations, we have to use IMS, industrial methylated spirit, which contains some methanol as well. And obviously these two fluids physically are poles apart, so you have to be a little bit careful with delicate tissues during the transference from, say, formalin, which is a sort of aqueous specific gravity, into something like IMS, which has a specific gravity of around about 0.8. Otherwise, you get all sorts of shriveling and so forth occurring. You get what's called osmotic syneresis, which can distort tissues and rather spoil the look of all the rather nice things that you've preserved. So it's not too difficult. It just takes a little bit of time and trouble, but no problem at all. And of course, DNA is stored perfectly well in IMS, but there are other preservatives for it as well, which are much, much better. And although I'm not a molecular biologist and I only understand the sort of basics about DNA and RNA and so forth, at the same time, I leave that to the specialists in those sorts of fields. And when I'm teaching people about it, sometimes I will come across someone who has really studied and has a vast experience. And I find not just teaching them to suck eggs, but at the same time, they will give me a whole lot of pointers, and then I can update my course notes and information and pass that information on, which is very, very generous of them.
So, Simon, I imagine it is your primary objective as a conservator to ensure that every specimen that you work on is preserved to the best of your scientific ability. But is it ever vital or useful to leave specimens that have been perhaps mispreserved so that they act as records of taxonomy and the evolution of techniques, like the ones that you've already mentioned and have been speaking to me about? So, for example, a specimen that perhaps didn't have the fats fixed properly, so therefore they've leaked out of the specimen, spoiling the liquid and therefore discolouring the solution? Or are you always trying to repair and correct specimens that have been preserved?
Yes, this does happen occasionally. Usually it's through deterioration. And although specimens in fluids, providing the correct pH, etc., will remain stable for a long time, i.e. 50 years maybe, you do get problems where you do get specimen interaction, sometimes due to a lowering of pH. A fine example of this is where you get lipid seeping, and particularly from cetacean, i.e. whales, dolphins and so forth, which have a lot of blubber on them, and the tissue is very, very fatty indeed. Other fish have oils in them, particularly from the liver, which can seep out gradually into the fluid. And because lipids are never easy to fix, in fact, they're almost impossible to fix, and formaldehyde does not fix lipids, it only preserves them. They still escape from the body, and then they make contact with air on top of the fluid, and then they oxidize, they can form fatty acids, and then, hey ho, the pH drops and the specimen starts to deteriorate.
Why are lipids so hard to fix? What is it that's creating a problem chemistry-wise?
uh,
Have I opened a can of worms here? No pun
it
intended.
is a bit of a can of worms, actually. At the moment, as far as I know, nobody has yet found a successful way of fixing lipids. The only way they're shown or demonstrated in histology, certainly, is by freezing the tissue and doing frozen sections. And I did those when I did the Paddington course, and they showed us how to use freezing microtomes and cryostats and so forth, which they tend to use in hospitals these days for doing quick sections of biopsies and sort of possible dodgy tissues taken out of people. So lipids are always a little bit of a nightmare, and they do cause all these sorts of problems with fluid preserved specimens.
I was just going to say, the whole objective of storing these specimens, is it something greater than just records of the species that exist on this planet? Are you extrapolating some specific data for the purpose of medicine? Is it informing another industry? Or is it just purely for the collection of natural history?
Basically, it is for the collection of natural history. You're looking at the morphology of these animals, plants, organisms. Sometimes researchers come along and find something completely new about them. Great, all for expanding the information we have. Vital, really. It is really their speciality. Sometimes it may be for a PhD thesis that they're working on, and getting on very well with it. So you just never quite know.
So the specimens that are very fragile, I'm thinking about things like jellyfish or perhaps fungus. Could you please explain to me how one would go about, if at all, conserving a specimen like this? Let's say that a tentacle comes off of a jellyfish. Is it possible to repair specimens of this fragility?
Yes, it is. Years ago, when I was working at the Natural History Museum, that well-worn phrase, I was shown how to use nitrocellulose solution, which we used for embedding large tissues in to do histology, called celloidin. And it also goes under the names of necaloidine, or the French call it collodion. But basically, it's a solution of nitrocellulose in a very flammable mixture of diethyl ether, solvent ether grade, obviously, and absolute ethanol. And I was given this to work with, and one of my first projects with it was to glue, if you like, some moist alcohol preserved salmon eggs onto a sheet of glass vertically. So quite challenging, and after a few minor mistakes, I eventually started to get the hang of it, and it is extremely good, very effective. The only limitation is it only works in alcohol solutions, not work in formalin, because the two fluids are immiscible. Having sorted it for alcohol, so any jellyfish preserved in alcohol are easy to repair. You just glue the bits back on with celloidin, and it works a treat. Most jellyfish are preserved in formalin or aqueous solutions, glycols and things like that occasionally, diluted formalin, so half the fixative strength. And then you have to use a gelatin solution. So a little bit more difficult, because it's a very special solution containing also trace of acetic acid, which acts as a fungicide, and also some glycerin to basically keep it gelatinous, if you like, so it doesn't dry out. Things like that have to be glued on, if you like, using gelatin. Now, the only problem is that whereas celloidin will go on, as far as I know, forever and ever, gelatin will eventually hydrolyze after about 50, 60 years, so it's quite a long time anyway, and the specimens will come apart, fall off again. So it's always been a bit of a problem, but so far the gelatin technique does work quite well, and I've even managed to mount small alizarin specimens, which are those stained with alizarin dyes to show an internal skeleton, been macerated in potassium hydroxide and stored in glycerin. So really, really sort of gloopy, sticky, yucky sort of things. Very, very difficult. And gelatin works an absolute treat for them. And I've mounted them on sheets of glass preserved in glycerin, in this case, and they've worked an absolute treat, and they're still stuck on. So, but for how long, I don't know.
Is that in any way similar to diaphonization?
Yes, it is. Yes, diaphonization is a rather misleading term, I find. I think it was coined by the Americans, but I've always called them alizarin transparencies because diaphonization sounds a little bit like diaphanol, which is a chlorine dioxide solution dissolved in dilute acetic acid. So it's completely different.
Oh, okay. Yeah. It put me to rights there.
That's okay. No, because no, you weren't wrong. Diaphonization is the term, but
Mhm.
as I said, it is rather an Americanism. But myself, who've actually used diaphanol to soften chitin when you're cutting microanatomical thin sections of insects and spiders and things, who have to have something to make the chitin exoskeleton softer.
Mhm.
Otherwise it shatters when it hits the microtome knife, which is not good, and which worked a treat, which I published a paper on back in about 1973, I think. Anyway, the two terms get a little bit confused from that point of view. That's basically what I call alizarin transparent, which I was gluing some, I think there were tadpoles showing a little bit of endoskeleton, and they needed to be mounted. And I thought, there's a much too fragile to sew onto a glass plate. I'm going to have rather a high casualty rate. So I started to do it with the gelatin, and hey presto, it worked. So I thought, phew, thank goodness, sigh of relief, and they all look very nice.
That is absolutely amazing that you are able to work on something so small. And I think of a tadpole and I think they're sort of small and squishy, and that their genetic makeup would be too fragile for you to work on. So that really is quite incredible.
Well, they should be on display, I think, in the Grant Museum, which is the Zoology Museum of University College London. So hopefully they'll be on display and not behind the scenes in storage. I think they mounted an exhibition on alizarin transparency specimens a few years ago, and they asked me to do the work for them, and there were one or two which needed repairing, and these were vertebrates and so forth, small vertebrates. There was one baby bird. I think it was a baby curlew or something, which had a detached leg. And I thought, oh golly, how am I going to be able to put that on? I thought, I know, glass needle technique, which was something I invented some years ago um, for repairing fluid preserved specimens which need a bit of weight behind. So sort of arthropod limbs which are not going to hold on with just dear old celoidin or something. They need something of a bit of an endoskeleton to hold them in place as well. And by stretching glass rods in heat, you can make little glass needles of different lengths, obviously, and widths as well, so different strengths. Um, and by applying a glass needle into the top of the femur of the specimen and then just snapping it off at the right level, it held it beautifully in place. Little blob of gelatin, cement on the outside, and the leg, as far as I know, is still in place. I have actually got pictures of it still, which I've kept as part of my sort of conservation record.
Yes. I think I might have come across that on your website actually, and it was very beautiful. It's a sort of stained looking specimen, a kind of see through, as we talk about diaphonization, how I visualize it. A sort of pinky blue specimen. Is that right?
That's it.
Yes.
Yep.
It's marvelous because the fix what you're using, the glass needle, isn't actually compromising the visual of the specimen.
No, exactly. And the other thing about using a glass needle is it won't decay either.
Ah, yes, of
Because
course.
if you use all sorts of other wires, needles, pins, whatever, a lot of them have copper in them.
Mm.
Copper, you'll get copper salts coming out, staining the fluid green and the specimen green, and I've seen all sorts of things like that. So glass, of course, doesn't react. Hooray! Fantastic. So really, really useful.
Oh, that's fabulous. It sounds from all the things that you were saying, Simon, that you primarily are a chemist. Moreover, would you say that that's correct?
There are some people in NATSCA whom I could name, who have much superior chemistry knowledge to me. I just did particularly organic chemistry was a really useful one,
Mm.
obviously, to A level back in 1960. It has held me in very good stead. Obviously, I've learnt a little bit more since then, but not a huge amount. But every now and again, somebody said, "Oh, we've been studying biguanides and so forth," and I think, Right, okay, and I had to sort of go and look it up and think, "Oh, yes, okay, right, now I know what it is, that's fine." But, it 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 does show my own ignorance and my own level of, chemical knowledge. So, basically, mine is sort of at the sort of intermediate level, I would say. But for someone who's done a PhD in biochemistry, they'd be streets ahead of me.
And one of the questions I'd like to ask you is talking a little bit about the specimens that were poorly preserved, and we did touch on that very briefly. We have made incredible advancements in our technology, and obviously you've named quite a lot of the technologies that you've had a handle on developing. Why do you think that specimens have been so poorly preserved up until now? Was it just that historically those discoveries hadn't yet been made, or was it something else? Was it that the environment of which these specimens were being preserved was not up to scratch, not in a laboratory, maybe out in the field or something?
Oh, there are all sorts of things there that you mentioned. Sometimes the storage area was poor. Some people regard fluid preserved collections as a necessary evil. They just sort of shove them to the back of a cupboard or something like that and hope they'll go away, or that someone else will eventually find time to deal with them. So sometimes it's a little bit based on ignorance, attitude towards them. And there was a very nice quote by Thomas Pole, 1797, who basically decried the need for fluid preserved specimens. This is in the 18th century, for goodness sake. Took up so much time and trouble. He obviously didn't like them, and he put it rather nicely. I can't remember the exact quote in wonderful archaic English, but basically saying that they took up much too much time and trouble, and they were an absolute, in other words, pain in the bum. Some people, unfortunately, do take that sort of attitude towards them and try and basically shortcut around by saying, well, if we just digitize everything. Yeah, you can digitize a lot, but you can't get away with everything. There's always somebody out there who's going to find something else in the future, which you can only get from a fluid preserved specimen and not from a digital image, even though it may be in 3D and goodness knows what, and looking at just about every single possible thing that the specimen contains. So you were talking about deterioration, and I did touch on that because I talked about the lipid seepage, but there are all sorts of other things as well. And sometimes specimens were stored in the wrong type of way. They were fixed in alcohol, and the chemical change that you get brought about by alcohol as opposed to formalin is reversible. So sometimes people will put things in alcohol, they will fix them in alcohol. The alcohol slowly evaporates, as I'm afraid it does. The level drops, the concentration of the alcohol also drops with it, because after all, what's being evaporated is the pure alcohol, and eventually you'll end up with a 10% solution of alcohol in water, which is not a very good preservative at all, and the specimen rots. Once it falls below 30% alcohol, it's on the danger list, and it can get degraded by fungi as well when that happens. So there are all sorts of things that can attack it, if you like. So you do have to be able to keep an eye on them. You do get a lot of discoloration, not just through lipids, sometimes other interactions, particularly with alcohol, because it is a powerful solvent at the same time. And providing the discoloration stays clear, then usually the specimen is fine. If it goes at all cloudy, then you've got problems, because there's all sorts of other interactions going on as well, which are undesirable. So sometimes you get that, sometimes you get specimens that have dried out totally, usually because they've been put in the wrong sort of container. And often, as you mentioned, specimens collected in the field tended to be tended to be fixed rather crudely, and usually using glass collection tubes with cork stoppers, which are very porous. And if you preserve things in alcohol and then end up storing them in alcohol with cork stoppers, the alcohol will quite quickly evaporate and the specimen will end up a little dry little husk. From that dry little husk, you can usually rehydrate them, bring them back to life, but they're not quite the same as the original specimen, obviously. So there are many deteriorative mechanisms always out to get your specimens, and as I'm sure you know, particularly with taxidermy, you do get a lot of insect pests.
Simon, I have a question. Do you think that we, as researchers, as scientists, are always going to be, quote unquote, chasing our tails on preserving specimens? And what I mean by that is, do you think there will ever come a point where science is so advanced and we have completely understood how to prevent specimens from deteriorating that we can guarantee the preservation of a specimen indefinitely?
Ooh, now that's a tricky one.
I imagine organic material, it always has the susceptibility to decay, whether it's fixed or not.
Oh, definitely, it does. All the time, as I just said, there are things trying to get to it, basically to decay it. It seems that nature is determined to decay, and because I've worked on fungi a lot, I see the action of fungi breaking down all this sort of waste product as plants decay, trees drop branches, obviously, and so on and so on.
Yeah.
Um, so all the time, this is just part of the natural process. We can't really go against that. But I think in time we will hopefully find the panacea to fixation, which is going to be user friendly, which is going to evaporate, which isn't going to be toxic to us, etc., etc., etc. We just go on waiting and hoping somebody will eventually find the time and have the knowledge and technology to be able to see this through, and it'll just make our lives a whole lot easier.
Do you think there's a priority? Do you think scientists are seeing that as something that is important to preserve records of our natural world? Or do you think that's sort of on the back burner? I mentioned funding very early on in the conversation. Do you think that there's room and space being made for that kind of research?
Alas, no.
I thought that might be the answer.
Oh, very, very annoying, frustrating, I must admit. Because yes, obviously collections are important, but the debate is always going on. Oh, collections take up so much room. They're always expanding. They take up more and more space. They cost us lots and lots of money. And most of the time, it nearly always comes down to money. Oh, alas! And then it starts getting really political, and that's why I start jumping up and down in frustration and saying, "Can't you see what you're doing?" And we need to understand the natural world if we're going to coexist with it for any much longer before we destroy it, etc. Oops, sorry, I mustn't get too negative on this.
Well, the irony is that obviously specimens and natural history specimens are taking up so much room, but they're taking up room in the sense that because we're losing them in the real world. So they're existing only in history collections. And then, well, there'll come a point where they might only exist in history collections. So they need to exist in that state.
Yeah, well, exactly. This is just another really, really vital point. Take, for example, Clarendon Park, which a few years ago, and alas, great shame, very great shame. I won't say it burnt to the ground, but certainly all the interior went. With it went a whole mass of taxidermy, some of which I'd conserved some years before, which included a large collection of Australasian birds, including extinct specimens like huias, rare things, endangered things like kakapos, keas, etc., etc. All sorts of really, really interesting specimens, and they all went up in flames, a whole lot. I must admit, I thought I slightly died because it was one of my favourite projects in there in my early days, which I did, which was conserving a large multi-birded case which had been in his lordship's bathroom and had really suffered. And with some help from a very worthy intern who was working with me at the time, we managed to bring the whole thing back from the grave, so if you like, back to a proper preserved specimen. The birds all had their correct eyes, glass eyes, put back in the correct specimens. Oh, it was a real challenge, but I loved it, and I learned so much from doing that as well. But that's just an example of just the sort of thing that can happen. These disasters strike. Unfortunately, it's just one of those things. And if a whole load of extinct specimens go up in smoke, we sort of grit our teeth, and some people say, "Oh well, never mind." But I'm saying, no, 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 it's not just never mind. These specimens are gone; they're extinct, and now another 6 or more specimens have gone up in smoke, and we shall never know them again. Sorry, I'm getting a bit dramatic now, which I mustn't do.
No, no. I mean, it must have been absolutely heartbreaking, and I definitely felt a little clutch in my heart when you told that story. I can definitely empathise. Do you have any thoughts on integrated pest management? I know that some museums are on board and others aren't. Do you share any thoughts on that?
Definitely, because I do work for the National Trust. Obviously, pest management is vital, and nowadays, all staff, all house staff, particularly, well, they don't necessarily have to have natural history collections, of course, because the pest tackles all sorts of other media as well. So they all have to undergo basic IPM, which is really, really good. And sometimes when I go visiting the properties to sort of check that everything's okay, which I do annually, obviously not this year, alas, then they show me, oh, we found this in the sticky trap. Can you tell me what it is, please? And I either say, oh, yes, it's a spider beetle, or else I say, no, that's a beetle from outside, just from the gardens or something like that, just happens to have flown in and got trapped and won't hurt the collections at all, because they're always keen to try and understand what the various pests are and therefore how to deal with them. And because recent regulations have removed a lot of the teeth from dealing, i.e. insecticides and so forth, which we used to use, some of which were rather non-PC, it's made my job somewhat more challenging, but at the same time, somewhat more lucrative also, because I get a lot more work having to deal particularly with taxidermy pests and specimens which have been munched. And occasionally I do get given something and I think, oh dear, I'm afraid I cannot do anything with that. Once or twice I've been shown specimens which have suffered very severe clothes moth damage, and as I'm sure you'll know, when all these, if it's a bird specimen, all the feathers have been munched away completely, and you just basically got the taxidermy mount covered with frass, cotton wool, and lots of bits of detritus and wire and so forth poking out, and they say, can you do anything with this? And I said, well, yes, you can keep the glass eyes because they are recyclable, and the rest can probably go in the bin. And you think, oh dear, it's such a shame. So always, I'm having a problem. But sometimes one museum said, can you do anything with this kakapo specimen? And I thought, wow. And it had carpet beetle problems, and basically the entire back of the kakapo was nude, just bare skin, but at least surrounding it was a sea of feathers. They were all still there. And okay, yes, it did take me a while to be able to rebuild it, but sorting out all the feathers and the lefts and rights and so forth, and then working out which went where, and then slowly rebuilding this specimen's back plumage, which I did over a few months, just doing a bit each day, and it worked. So it depends entirely on the types of pest you're getting and the damage they can cause.
I imagine you were probably being awfully careful not to sneeze whilst you were fixing that specimen back up.
Indeed. Well, yeah, I mean, I had some perspex covers with which to cover the specimens when I wasn't there, or sometimes even I'd just select out the feathers I needed and then cover the others back up again, just in case, yes, I sneeze. If you've ever done paraffin wax microtomy, you will know all about controlling your breathing, sneezing, coughing, anything like that. Or if someone comes up to you, you say, stay back, please, because any sort of air draft can cause a complete disaster to all the sections that you just cut.
Oh goodness, I can only imagine. We were talking a little bit about insects and pests and things. I have heard through the grapevine, and you know what I'm about to ask you, that you have the ability to identify a few spiders just from seeing their webs. And this fascinates me. I'd love to know more about this. I'm actually a little afraid of spiders, but I would love to know more about this and whether or not you think that if the spider's web is identifiable based on the spider that's creating it, that therefore means that the design of the web is a genetic aspect of the spider.
Well, it's a very interesting question. I can't answer it definitely, but I can say that yes, there is a certain truth in that, because there are certain types of spiders' webs which are very easy to identify, particularly the classic one, which is what's called the missing sector orb web spider, which is a spider you get usually associated with houses and so forth. Its scientific name is Zygiella exnotator. And it's one of the first spiders I came across when I worked at the Natural History Museum, because I brought one in to my then boss, and I was a complete neophyte then, and said, excuse me, what's this one called? And he said, oh, yes, that's Zygiella exnotator. It didn't have an English name back then, so we just sort of rather vaguely named it the X-mark spider. But one of the characteristics of this, and goodness knows how, if you look at a Zygiella web, you'll find that there is one section of its web, usually near the top, where there is no spiral thread. You know the spiral thread? Well, there is no spiral thread, so there is two sort of sections looking rather sort of arrow-shaped with a central thread, which is the trigger thread. And if you follow that back, you'll find the spider in its little hidey hole. So it's instantly recognizable. And they tend to find, we tend to get them on wing mirrors, but also, as I said, on windows on houses too, so that when you light up in the evening, all the night-flying insects are attracted towards the windows, of course, and the spiders then have a nice feast. So it's very opportunistic and clever of them, I think, to be able to build webs in exactly those places where they know that every evening they're going to get a feed. So that's just one of them. There are various others too, which have various characteristics. There is another one where you will see go during the autumn, you tend to get a lot of what are called garden spiders, which are the classic orb web. They have a central hub in their web and they're very easy to spot. And they are daytime spiders. But sometimes, again, if you go out in the country and look on gates, fences and things, you will see an orb web there with a hub in the middle, but no spider. That's usually the walnut orb weaver, as it's called, Noctinia bratica, which only comes out at night, or if something actually happens to fly into its web in the daytime, it'll make a quick appearance and try and grab the prey and then retreat back into its little tiny crack, fissure, whatever it is that it's hiding in. So that's another one you can do slightly more analytically. Then there are the tetragnathas, the long-jawed spiders, which you tend to build slightly smaller orb webs, which you get in nettles particularly. And another one which has a hollow hub. In other words, there's a hole in the middle, a little bit like a polo mint, not quite the same proportions. But if you look at the hub, there's a little network around it, and then the actual center part of the web is hollow. So if it's a big enough one, you can actually poke your finger through it. It belongs to a spider called Metallina. I'm not quite sure of the proper English name for that one, unfortunately. That's a very common countryside orb web spider. And then there's another one, oh gosh, I could go on forever, called the wasp spider, which builds stabilimentum into its web, which is a sort of very flocculent zigzag pattern. And in this country, we have one in the south particularly. And if you go out on a sunny day and you see these zigzags, you'll usually just see the spider there as well, because it's nearly always on its web. And it builds this stabilimentum into its web so that if a grasshopper happens to hop into its web unwisely, then the web is strong and stretchy enough to be able to hold the grasshopper while the spider then scuttles off to where it's been caught and then can wrap it up and subdue it. That's another characteristic as well. Otherwise, after that, it sort of goes a little bit more, well, is it a sheet web, tent web, triangular web, and so on and so on and so on. So there are various different types of web as well. Does it contain cribellate silk? Is another one, because there's another type of spider, very common, which you get on sheds and so forth. Builds a little hole with slightly bluish, thick silk. It's called the lace web weaver. And that has an additional spinning gland called the cribellum, which makes this very, very thick flocculent silk, which, as I said, has a slightly bluish tinge, and that's Amerobius. And you know everybody's favourite, the house spider, which freaks a lot of arachnophobes out because they tend to scuttle around, and particularly during, again, the late summer, early autumn, when the males mature, they're even leggier than the females, and they tend to scuttle around in the evening looking for love. And if you have a cat, the cat will often chase them. So suddenly you can be sitting watching the telly, and suddenly the cat gets all alert, and then next moment it darts off the sofa and launches itself at something on the other side of the room. And nearly always at that time of the year, it'll be a male house spider who will probably end up getting crunched or played with. So usually rather mangled, unfortunately.
Have you learnt about these spiders out of? It's not something that you've needed to use in your professional line of work. Is this more of a passion for you?
It is more of a passion, yeah. Yeah. And whenever anyone's having a bio blitz where they want a certain nature reserve, all the animals and plants, or as many as we can identify in a day or 48 hours, sometimes a weekend, they'll ask me out if I can do the spiders for them, because there aren't that many arachnologists in the area, unfortunately. And I'll say yes, certainly. And there's a new book come out, a new ID book with lots of lovely, really detailed colour pictures and descriptions, and that is particularly good for helping. There are also, there's a Facebook which is very good, and they're always extremely sympathetic to arachnophobes and will try, like I have just done, to try and get you interested in the spider, because that's one of the things I always do. If I meet someone who's arachnophobic, but willing to overcome it, then I will always try to get them interested. And if it's a nice summer's day, we can go out for a walk and I will show them spiders and webs and spider behavior and this and that and the other. And usually by the end of it, and also how to sex a spider, which is very easy. And by the end of it, I know when I've scored, because I can tell that they're really interested and they're asking lots of questions about them, which is good. And then I tend to say, well, you know your own fear, you know really what causes it. And they say, well, sometimes it's the hairiness of the spider. And I say, yes, okay. And I know if you look at them face on, they're a little bit unprepossessing, with all those big fangs and lots of eyes staring at you or glittering at you and so forth. You can really dramatize it up a bit. But basically, what usually spooks people the most is the way the legs move so rapidly. And although we don't have them in this country, if you go into warmer climes where they have the huntsman spider.
Ooh.
Oh, she's shuddering already.
Go on, no, I'm keen to learn.
Yep. The huntsman spider is one of the heteropods, they're called heteropodids, and they basically have sideways legs, the pterygoid legs, so a bit like crabs do,
Yeah.
and they can move sideways as well as forwards, and extremely rapidly. And when I worked at Natural History, somebody found one in bananas and asked if I'd look after it, and I said, yeah, I'd love to. And every day I went to renew its water, because they need water, or give it a few flies I'd caught, just to keep it happy. Damn thing would always get out. A little flurry, it would run up my arm like a shot, jump off the back of my back, scurry across the floor, and hide in always the same corner. So I sort of got used to this thing, and every time it went to the same corner, I went and caught it again, and we went through the same routine every bloody day. Damn thing. Ah, dear, oh dear. All right, so at least it was predictable, and then by then I'd have the water done and the flies in the box, and then I'd have to get the spider back in the box without letting the flies out, and then it would rush around in there like a hurricane, each catching all the flies and looking happy, and only then would it calm down. Sorry, you were going to say?
No, I was just fascinated. I once read somewhere that the reason that people are arachnophobic, in part, is because the way that you move, as you mentioned, obviously is very random, and because the brain cannot predict random motion, it is jarred when something moves in that way. I wonder if there's other elements that you think are coming into play, because arachnophobia is so common. I mean, it's one of the biggest phobias people have. Is it just because the way that spiders are sold to us as creepy crawlies and they have such a bad reputation? Is it the portrayal of spiders?
Yes, it is to an extent, because after all, they are predators. They are one a predatory group. In fact, I think that's true of all arachnids to an extent. But also, when you get films like Arachnophobia, where they're really dramatized up, and basically it's a load of hoo-ha. You see people getting bitten and dropping dead almost on the spot, and I'm thinking, yeah, well, yeah. I mean, even the most venomous spiders in the world couldn't do that. But there we go. There's a huge amount of artistic license in them, and the fact that they can all jump huge lengths and so forth. Well, yes, there are some which are tiny, called the jumping spiders, the salticids, which are usually people's favourites. And
They're quite cute, aren't they? They're quite little and cute.
if you want to see something amazing, you look on the internet, and there is a jumping spider called the peacock spider.
Okay.
The males have this wonderful mating display, and the females are very predatory indeed in this particular group. And if the male muffs his display, or she's feeling particularly hungry, she'll just eat him. And it's such a shame, because when you see the male performing, and he is tiny, he's about the size of a rice grain,
Oh.
and you get them in Australia, and they're quite difficult to spot until you get your eye in. But the display is just incredible. They're very, very colourful indeed, as you'll see. So do look up peacock spider when we finish, and, and be amazed. Hopefully.
Oh, absolutely will. I mean, even just talking to you about spiders for the last however long, 10 minutes, I am excited. I do want to learn more about them. But I think I would be able to get over my fear if I just gave myself a chance to learn. You are very passionate and just researching, and the way that I found you was actually through chatting to other taxidermy friends in the community. So you've come up quite a lot, and it's clear that you are revered in the industry for a whole host of different things and the hats that you wear. But what is it that you most enjoy about the job? What still gets you out of bed in the morning? What excites you?
Yeah, good question. Basically, it's something that's going to challenge me, and every now and again, I get one big time. Recently, I had a big butterfly case which came in, which someone had bought from an auction house in Ireland, and the carriers had presumably dropped it or it had had an accident, and the glass cover had smashed, and gone straight onto the butterflies and wreaked carnage amongst them, is all I can say. And she was very disappointed, but then she said, "Can you do something with them, please, Simon?" And I thought, help. And I looked at them, because although she'd taken the worst of the glass out, it was an absolute mess with wings, bits of wings, legs, antennae, all over the place. And there were about 100 specimens in there. And I thought, well, come on, it's locked down. It was locked down then. it'll keep me off the street corners and all that sort of stuff, you know. Sorry. But I thought, no, I'm going to do this as not exactly a penance, but a real challenge. And by golly, it was. I must have used about half a ream of Japanese tissue on them. Well, we're exaggerating there because it's a very small amount actually. But certainly a lot of patience, there was quite a bit of eye strain. I had to wear a visor, obviously, when I'm doing this. But just taking it slowly,
Mhm.
and gradually they started to come back together again. And then, of course, I get encouraged. I usually do all the easy ones first because I know they're going to work. And then once I've done that, then I feel buoyed up enough to do the really challenging ones. And those did work as well. One or two of them turned out not quite as good as I would have hoped, but they were still sort of good enough, if you like. Because of course, the only problem when you're doing something like that, if it cocks up, tough. There's nothing you can do to reverse it, I'm afraid, because they're just too fragile and they won't take a reversal. They just won't do it, I'm afraid. So if it ends up, if you'll excuse the expression, buggered, then I'm afraid they're going to remain like that. Ah, so
Well, that was one of the questions I actually had for you was, at what point is a specimen irreparable? And I imagine that entomology is probably one of those things where, well, I don't know, not all entomology, butterfly specifically, because I suppose a beetle is more robust, or some of the other bigger animals, you could get a replacement part, but maybe the butterflies, because of the way that their wings are made up, it's just not possible.
yeah, basically, if there are bits missing, then they are virtually impossible. You can't recreate a wing
Mhm.
unless you're a particularly good artist and have got you don't mind spending ages and ages with a very very fine brush doing all that sort of work. And there aren't many people I can think of who would have that skill. There's one who died a few years ago, a chap called Brian Hargreaves, who illustrated lots of butterfly and moth books, and who was an exceptionally good artist in that genre. And I knew him when he worked at the Natural History Museum, and I got one or two of his examples of his work. They are absolutely stunning, and they are so exact. People look at them and think they're looking at a specimen of an actual butterfly. So someone with that sort of skill would be able to do it and reproduce them. But when I was doing this case, there was one particular specimen which only had 3 wings anyway. I checked on her original page where she showed the auction entry, and sure enough, the butterfly only had 3 wings there. So I thought, well, that at least isn't my fault, if you like. So yes, every now and again, you do get something which is just impossible, or pretty much, or else you've got to spend an awful lot of money hiring someone out to basically recreate something like that.
Sure, sure. Well, this is going to be my last question for you, although I feel as though I could talk to you for another 2 hours because I have so many questions, and I feel like we barely scratched the surface, but I'm going to have to have to draw it to a close at some point. Um, what, if anything, are you still yet to do or discover or achieve? Is there anything that you'd still like to do?
Well, I'm always hopeful. There are now more natural history conservators out there, and some who are a lot younger than I am. I'm getting a little bit long in the tooth now. Hey ho, not surprising. It happens to us all, after all, etc., etc. But although I am not willing to take retirement just yet, I'm willing to let a lot more people do this sort of work. So if a challenge comes along, then sometimes I might invite someone to come and help me solve the problem, if you like, and at the same time give them some interesting work experience, which I've done in the past. And sometimes I'll take people on a sort of short-term contract, if you like, and it's something they can quote in their CV. So it's always useful. And from my point of view, it's useful to have someone else to help, because sometimes the work can be quite onerous, particularly if you're working alone. And particularly if you're working on something like large red deer head, which I'm sure you know has lovely big antlers, and trying to get them into the workroom is rather challenging. If you've got somebody there, they can help you. And then always you've got it on your workbench and there are these antlers pointing out into the room. I had someone working here. She was great. She was absolutely fantastic, really useful. But we had to do the antlers in the summer house because the summer house has wide doors on it, but it's not very deep. So all the time, whenever you were bending over, sometimes you get an antler between your legs or something. You had to stand up rather carefully, or else you bump your head on one of them. There was a certain amount of cursing going on. Yes, an antler in a tender spot is not not particularly pleasant, I must have.
I'll take your word for it.
Oh dear. So yes, you do get things like that every now and again. And also that particular specimen had lots and lots and lots of bald patches on it. And one thing I'm very, very keen to do is learn how to develop my skills, in this case. So someone else is going to teach me for a change, hooray, how to do needle felting to replace missing fur. Because this is a technique which one of our NATSCA members came up with a few years ago. And she was learning how to do this and teaching herself, as far as I can see. And some of the results were really impressive. And I thought, wow, that's really, really good. Because before I've had to sort of bind bits of fur and then sort of colour them and texture them to make them look good. Or else I've had to, in some cases on skins and things, do a lot of brushing, in which case you get a certain amount of hair extraction because some of them are loose. And then you just recycle them over the bald bits in little adhered on swatches and so forth. But certainly being able to replace it with something like wools and so forth, really, really good. And her work looked really, really impressive. So I'm hoping she'll do a 24/48 hour course in needle felting, and I'll be able to develop my skills on that, because it would then become a very important part of the taxidermy workshops that I do. So yes, always new challenges out there. And while my hands are not shaking, thank goodness, and the brain still functions, which is very important, I find, because work always makes the brain function, even though my mind is slowing down somewhat, which is rather annoying. But then it all comes, I'm afraid, with the aging process. So basically, there we go.
Oh, well, thank you so much, Simon. It's just been a fantastic hour and a half, 2 hours, and I don't know how I'm going to possibly cut this down. I don't want to take anything out. So thank you for being on my podcast. So there you have it, my conversation with Simon Moore, Conservator of Natural Science and Natural History. I really hope that you took something from that conversation. I know he taught me heaps. It was only in listening back did I really realise how much I actually learned in that conversation. So if I'm learning, I'm hoping that you are too. If you would like to find Simon, whether that's to make contact, join one of his training courses, or just have a little look at the work that he has mentioned, you can find him at natural-history-conservation.com. And Simon also has a Facebook page with the same handle, Natural History Conservation. You can find me on Instagram at Elle Kaye Taxidermy. You can find the podcast at its own Instagram at Specimens Pod. We're also on Twitter at Specimens Pod. If you're following us on these platforms, then you would have already seen that we've just launched our brand new range of merchandise. So if you'd like to stick the beautiful artwork by Madison, Erin, Mayfield on all of your possessions, whether that be a laptop, a phone, a water bottle, then check out the link. I'll put all of the information in the show notes and you can find us on the platforms already mentioned. Thank you again for listening. I'll see you next time for episode 8. Lots of love.